let's transition to our final objective of today. And let's put these lessons into practice as we hopefully complete part 2 of the groceries exercise. So in today's agenda, you will see a link to our in-class version of the groceries exercise, and that's what I'd like for you to reference. Or if you have been working in your copy of the groceries exercise, I'd like for you to bring that up now. So we're going to focus the next 10 or so minutes, 12 minutes on finishing the groceries exercise, and maybe we could do it pretty quickly. I'm going to bring up our in-class version and you could follow along in the front of the room. But if you've been working in your own copy of this groceries exercise, I'd encourage you to bring up your copy now as we try to tackle part 2 together. Previously, we had tackled part 1. Remember, in this groceries exercise, we are provided in a setup cell, I guess a function called 2USD, and we'll run this cell so that if we want to use the 2USD function, we could use it. Although I think most of our usage of this function is done in part 1, which we already finished. The other setup cell that we're going to need to run is the cell that has our products variable in it. And we looked a lot at this products variable and we investigated its structure and we saw that it is a list of dictionaries. And we were like looping through it last time. In part 1, we tried to just loop through each product and print out its name and price. And we had to do some sorting. And that was good practice of sorting items in a list. And we wound up with something like this. For each item in our list of items, let's print, since our item is a dictionary with a key of name, let's print out that key. And also, since our dictionary has a key of price, we'll print that out as well, passing it to the 2USD function. Hopefully this is a recap of what we did the other day. And that helps us arrive at our list of products. And then we sorted them, I guess, using the sorted function. And since we're sorting a list of dictionaries, we had to say, well, on the basis of what key should we sort these items? And we chose the name key. And that's what gets us our list of products. And that's what helped us complete part 1. So we're working with a list of products and we're just kind of printing them a different way. Now in part 2, our goal is similar, but we want to arrive at a list of the departments. And so we don't have a variable called departments. We have to derive this list of department names, babies, beverages, dairy, eggs, etc., from our original list of products. So where in our products does this department name exist? If we print, like the first product, for example, product 0, that might help us investigate the structure of any one of these product variables. We know this is a dictionary that has keys of ID, name, department, aisle, and price. Okay, so the departments are within each product, and there are some products that have the same department. So our goal is to just print a list of the unique departments first. That'll be our first goal. We want a list of department names like babies, beverages, dairy, eggs. We know that these departments are within our list of products. Let's get started by looping through each product and printing its department. And then we'll iterate from there. We won't try to do all this in one shot. We'll just take it one step at a time. Let's start. So our goal here is we want to arrive at a list of just the department names. And then maybe just a unique list of department names. Can we start by looping through each product and printing the department of each? Then maybe we can collect those departments for later. That's the kind of thinking that I would encourage you to employ here. Let's not try to do all this at the same time. Let's break it up. We'll probably start with a loop. So I'd love a volunteer. We have our products variable. It is a list. How can we loop through each item in our products list and print its department? Go for it. Yeah, like I'll just call my departments equals empty list. Sure. Oh, you want to do list comprehension?
Yeah.
Sure, let's do it. Yep. Yeah, that's it. We could alternatively do this the long way that we practiced. And if you want a reference to the long way, we could totally do that. But this would be the short way. So I guess the long way would be like departments, or even just to get started, like 4P in products, print P department. That's how we could get started. We see that we have some duplicates that we'll need to take care of somehow. So we could start like this. Start by looping through and just printing the department of each. If we wanted to collect it for later, we could do that like departments equals empty list. Now, instead of just printing the department name, we can collect it. Departments dot append. And now print that departments variable later. So this would be another iteration of what we need to do. And now we wind up with 20 different departments. And what we heard is, sure, we could do that the short way as well, using a list comprehension. All the department names, snacks, pantry, beverages, frozen. Oh, but there's a pantry again. We want this list to be of unique departments. Maybe we could figure out how we might do that with a list comprehension later, but maybe it would be easy for us to work within the context of a long way loop here. For each item in our products list, sure, we could print out the department name and collect it unconditionally for each item. Could anyone think of an approach where we're only going to collect the item if it isn't already in our list? So we'll only arrive at some unique departments? Thoughts?
Would you have like another if statement before the print?
Yeah, if what?
If
I'm just going to move all this stuff we were doing inside this if statement. And so, yeah, what the if condition is what? I'm listening.
brackets, quotation marks, department. And then the syntax is in,
Not in?
not in. And then the departments.
Perfect. So sure, we could like print and collect all the departments. Or if we only want unique ones that we haven't collected before, we'll say, all right, we'll only collect this department if it isn't already collected. And that's what helps us arrive at our unique departments. Nice. So here's unique departments, one way. Heads up, some other way of arriving at unique departments actually is to convert it to a set. So if you wanted to do this long, the one-liner way, we have a list of 20 departments We could then say departments equals list, convert. Here, I'll show you what I mean by this. We're gonna take that list of all the departments with duplicates, convert it to a set data type, which we haven't talked about yet. You may have seen references to the set data type in the container data types overview notebook. A set data type is like a list, except that it doesn't allow duplicate items. So if you have a list, and if you want to remove duplicates from it, you could do this approach. Convert it to a set to remove dupes. And then convert back to a list. And now this will remove duplicates. So now we only have our 10 items, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're just showing you some alternative equivalent ways here. All right, whichever way you choose, we now have a list of departments. And that's awesome. So, because we have a list of departments and our goal, I guess, is to print each one on its own line, let's just refer to what this goal is. Now we have a list that we could count. Remember, before we passed the products variable into the len function to count the number of products. And now since we have a list of departments, we can do the same thing, pass it into the len function to count the number of items. And it looks like we want to loop through here and print each item. So let's do that. Like for D in departments, now we're dealing with these department strings. So we just print D. And maybe we'll dot title case D. And since we want to sort these values, maybe we could loop through the sorted version of our departments list. And that gets us close to where we need to go. What we'll share right now is the remaining part of this is how do we count the number of products per department? And there's a few ways to do this. Some are more efficient than others, but our goal here in this introductory class is just to write some code that works. We should also we should have a focus on the readability of our code, at least when we're beginners and when we're not dealing with millions of data points. When we start to deal with big scale data, if we had 10 million products, then we would return and focus more on the efficiency of the code that we're writing. Are we doing this in the least amount of steps as possible? But since we have not big data and this is a beginner class, I encourage you to focus on the readability of your code. When we contrast two different solutions, I'll bring this up again. But anyway, so there's a few ways of doing this. But let's recap. How do we just loop through and print each department? So I shared this last class. I guess in order to arrive at a list of departments, we could do it two ways. The first way was to use our long way mapping technique. We know that when we're transforming items in a list, we could loop through them and collect some version of them into a new list that we set up starting as empty. But then as we loop through each product, we can collect or append to our empty list some part of the item that we're accessing. If we wanted to collect the entire product, we would just append P. But since our goal here is just to deal with the department names, it's okay. We'll just transform this dictionary into we just want to collect one of its attributes, the department attribute. So when our loop finishes, then our departments list will be full of values. Also, we added this condition to only collect a department if it's not already in the list. And that is one way of taking care of duplicates and removing duplicates. So that was one way that we arrived at this list of unique departments. So we'll need this list of unique departments, I think, to move forward. Although there are other solutions where you could do, there's different ways of doing this. So that's one way of getting these departments. The other is like, we'll still do a mapping operation, and we could do it either the long way or with a list comprehension that we talked about last class. This list comprehension, again, is just doing this mapping operation where we loop through an existing list and collect some kind of value and append it to an empty list. We're kind of shortening up that whole process, but we're doing the same thing here with a one-liner list comprehension. We're saying, hey, let's loop through each product in the list. And for each one, we want to concern ourselves with just its department attribute. Okay, and so now we arrive with a list of the department for each product, but we know there's some duplicates. So another technique we can use to remove duplicates is passing that list that has some duplicates in to this set function, converting this list to a set data type, which is like a list, except that it does not allow duplicates. So if we convert a list to a set, it will just remove the duplicates. And then if we want to keep doing list-like operations with this, we can then just convert the results back to a list. And that's what helps us arrive at our list of unique departments. And all this code was shared in Slack last class. Exactly right. Yep. Just to put a point on this, if we have like letters equals A, comma, B, comma, C, comma, A. If we print, well, what happens when we convert letters to a set? We'll see hopefully just A, B, C, not sure what order. It does, order is different. Cool. Yeah. So a trick there, if we know about this set data type, it's kind of like a list, but doesn't allow duplicates. Whichever one of these two approaches you like, go for it. But whichever approach we use, we now have a list of unique departments. So since the department names are strings, we could just sort them regularly. And then we could maybe store this sorted version of the departments back in another variable, or we could just loop through the sorted version. And when we do, we're just printing out each one. So this is half the battle. We're looping through the unique list of departments. And inside this loop here, we are noticing, or I guess we're leveraging the fact that each department name is a string. So for each D item in our list, in this list here of strings, each D is referencing the department name, which is a string, and we know we have string case manipulation methods that we can invoke on any string, like uppercase or lowercase. You may have done this in your rock, paper, scissors. And title case is one of those that gives us the capital letter at the beginning of each word. So heads up, dot title we can invoke on any string, like hello world. Dot title is essentially what we're doing here. All right, so let's put the final touches on this solution. And let's remember what our goal is. Not only do we want to list these department names in order of alphabetical order, we also want to denote, well, how many products does each department have? So sure, we could loop through these departments, that's all good, but our goal, remember, is we want to also say, well, babies, there's one product that matches that department. Beverages, there's 5 products. Any thoughts from you who are in the room about a next step for us that we could potentially take to arrive at this?
There's like a count function.
Yeah.
But it's like, so maybe something like for D and departments, like D dot count or some function.
Yeah, I think this is one of the solutions that I saw is like maybe we could leverage some counting, like essentially what we had in our list of departments. Oops, hello. Oh, I have to run all these cells. Let me just run all these cells. So if we had our departments and there's duplicates in, excuse me, if there's duplicates in there, then we could do this counting approach. So actually, let me like redo this solution to maintain some of the duplicates. Let's see. Just to do this counting approach, counting solution. I'd actually like to come back to this solution because it requires us to do things a little differently. But yeah, that's totally something we can do. We could use like a counting solution. We'll have to return to this in a sec. We could use a count of some kind. What's another thing that we've been doing to like count the number of items? There's like a function we use, len, right? So, okay, we know about this len function. It helps us count the number of items in a list. So working backwards from that, if we were to assemble a list of like all the products that have this matching department, then we can just pass that list into the len function and get a count of the matching products. So I think that's another, and that's the solution that I have in mind here. We'll return to this count solution as well. So let's start with filtering solution. So here we have departments, and it's a unique list of departments. And we are looping through them. Inside the scope of the loop, we'll have access to a given department, like babies, for example. Let's just see if we can look up how many products have a department of babies, and maybe then we'll incorporate this into our loop. But beforehand, if our department name was babies, how could we look up all the products in our original products variable and get the ones that match, that have a department of babies? Thoughts? We could maybe use a filtering operation. Our list of products is a list. So if we loop through for P in products, print P, we know that we have access to each product dictionary and that the department is one of these keys. All right, so sure, we could print the whole product. Getting closer to the concept we care about, maybe we can just print this dictionary's department key. Okay. So here we know the department of each product, and we know that in this example, we want to find the products. Maybe let's just try to print the name of the products that have a department of babies. Thoughts? Yeah. Could you help us out here? Any suggestions? Yeah. If this products department, I'm listening. Yeah, exactly. Either hard-coded babies, or since we stored this babies as a variable, I'm just using here, we could also use like D example. Okay. Yeah, we could just like print the product itself or something like that, or the name, it doesn't matter. All right, so here we're just using a conditional within our loop. We're doing this filtering operation. I think it turns out we only have one babies product, but now if we choose another one, like if we change our example department from babies to, what's another one? I guess beverages. Let's see. All right, cool. Now we have 1, 2, 3, 4, 5 products. Cool. I'm gonna share this in Slack here quickly, just so you have it. This is how I would start. Maybe I'm not sure how to, within this complicated loop or looping through the departments, how do I count the number of products? Maybe we can just break this up into smaller piece. Well, if we consider one department, could we do it for one department? If we can, now we can adapt this solution into our loop and make it more dynamic for each department that we care about. But we know that this works for a given department. If we wanted to collect these for later, how could we do a full mapping operation on here as well? Collect these. So like, we can say like matching products equals empty list. And now instead, in addition to printing the product, we can also collect it. Matching products dot append P in this case. And now at the end, we can print what is the length of our matching products. So we're iterating in very small steps. Sure, we could print the matching products. I'm just going to comment this out now, though. We can also collect them for later. And if we collect them for later, now we can count them by passing that list of collective values into the len function. So sharing this in Slack as well. All right. So also, if we wanted to do this in a one-liner, I guess, how could we do this in a one-liner? Quick list comprehension recap from last class. We know we could do any mapping or transformation or filtering operation. Any one that we could do the long way like this, where we're collecting some kind of item, we know we could do the list comprehension as well. How could we do this in a one-liner? We remember that our list comprehension starts and ends with square brackets. And we have some slots like transform return value for each item in our existing list of items, optionally if some condition is true. So this is the slots. For your midterm, I would recommend like making some notes about these patterns so that you can apply them. So for here, I guess it's just the same. We're looping for each P in products. So we could use that in slots 2 and 3 for each product P in our existing list of products, plural. We want, I guess, we'll collect the entire product. So we'll put that in the first slot. And now we only want to collect this product if some condition is true, if its department is equal to one that we care about. So this gets us our matching products. And then we could count them. So this is just a one-liner, but it's doing the same thing that we were doing above. So I shared this long way in Slack, and now I'll share the list comprehension equivalent. So no matter what our example department is, now we can essentially do a filtering operation. Oops. We want all the products, but only ones that match some given condition. If the department matches the department we care about. All right. Thoughts, questions before we apply this? We're going a little slower than I thought, but so there will be time for you to work on your deliverable, I promise, but this will help you on the deliverable, and I think is important. So thoughts, questions? All right. So exactly right. So we're doing this count for an individual department. So now how do we do this for all the departments? If we stick this inside our loop when we're looping through each of the departments, that's how we could do it for each department. And so that's the next step for us. Why don't we do this filtering operation we will print like the name of each department here. And maybe we can stick some of this filtering inside and try to get the products that match this department that we care about. Maybe we will print the number of matching products. I'll just do like a comma separated print statement here. For example, so we're starting to use this filtering approach inside of our loop where we're looping through each department, but there's something that we're going to have to change about this. There's maybe two things we need to change here to make this work. Thoughts? We're not dealing with our example department anymore. Let's see what would happen if we run this. Okay, it's counting something. What's going on here?
Only counting babies.
Yes. We're looping through each department and treating each department as this variable D within the scope of our loop. And when we're printing the department, we're referencing that dynamic department. But when we were filtering, we're still using this hard-coded string of babies. And so sure, with each passing of the loop, we could keep counting how many products have a department of babies, but really we want to count, well, how many products belong to this department that we're looping through. So how could we fix this a little bit? Exactly. We don't want to have some kind of hard-coded department that we are working with. Instead, we'll ask, hey, you know, this department, as we're looping through, it's going to be one at a time: babies, beverages, eggs, pasta. Why don't we use that in our lookup? And so instead of saying, hey, give us the products that match a department of our example department, since this is within the scope of our loop, we could use D here. This value that we're printing, it's like babies, beverages, and now this will give us a dynamic count of the number of products for each department. So I'll share this in Slack. This is like almost the final solution here, but it's the important part. Thoughts, questions? Yeah. Yeah, when we're looping through, as evidenced by us printing D and printing this line, basically just to revisit like what's going on with this loop is like, all right, Python's like, okay, you want to do a for loop? Cool. What's the list you want to loop through? Oh, your sorted departments, babies, beverages, blah, blah, blah. Okay, let's start with the first one. First one is babies. Okay, let's assign that to the variable D. And now within the scope of the loop, D will refer to babies until we get to the end of the inside of the loop. There's nothing else to do. Move on to the next item in the list. So with the first passing of the loop, we get this hard-coded print of a line. And then we get printing this department titleized and the number of matching products for this department, babies. And so now there's nothing else for the loop to do. So when it goes through all of the departments, now we're essentially doing this operation for each department, one at a time. Hope, does that make sense? Yeah. Cool, cool, cool. Awesome question. Yeah.
And then that means the P for P basically is saying that that's for each individual, basically an ID product.
Yeah, yeah.
Through,
exactly.
so you go through all of them and then we'll go through them again.
Exactly, exactly right. Through the departments?
Right, yeah. How do I know that it's
This is how I would tackle this problem. Notice that it may not be the most computationally efficient, and that's okay. The reason why it may not be the most computationally efficient is because like for each department, we're like going up and we're like looping through all 20 products again. With this list comprehension, where we're trying to do that filter operation and find the matches. So there's a lot of looping going on, but it's okay because we're not dealing with big data. We don't have millions of departments. Only if we had millions of products, millions of departments, that's when we might see this start to be a little noticeably slower. But if we're not working with big data, this is all good. And I think this approach is readable. And it makes sense for me when the list comprehension is your hammer, everything is a nail, essentially. Bad analogy there. All right, did I share this in Slack? Yeah. So, yeah, oh, no question? Okay, never mind. This is one solution for our part 2 of groceries. I think this is the one that makes sense to me. It's not the most computationally efficient, but it's readable, and so that's fine. Just to follow up on what we heard earlier, if we had if we did it differently, where we said like all departments equals, I guess here we could just use a list comprehension like P department for P in products. We're reaching back into our original products, print the length of all departments. Just doing a quick mapping operation here. And now these departments have duplicates, and this was what will help us count the number of items. So I'll show this in a sec. So as we're looping through each, I guess before we loop through each, what we could do is say like all departments dot count babies. How many times does babies appear in this list? All departments dot count beverages. How many times does beverages appear in this list? 5. So this would be another way, and it may be a little more computationally efficient, where we could stick this inside of our loop, like number of matches equals all departments dot count. Now, how would we need to change line 3? Exactly right. We're going to reference each department as we're referencing it, as we're passing through each iteration of the loop. Nice. And so now we could also print this. Cool. So this is probably like a more efficient way, but I would say if you want to kind of do this count, it's a little more limited in the ways that we can apply it. Then the filter operation is like much more broad. So I personally think in terms of the filter operation, that list comprehension we were doing in the first solution, but this is another solution. So like alternative solution using counting instead of filtering. First, we'll get a non-unique list of departments. We know we could count any one of them. Ask for how many items in the list have that value. And so now we could put this into practice in a little more dynamic way, like we heard. Awesome. All right, so that was groceries exercise part 2. We're doing some looping, we're doing some sorting, some filtering, some mapping, and those are the primary concepts we'll continue to work with next week as we prepare for the midterm. Oh yeah. Yeah. You'll either need to use string concatenation or a format string. So for example, just to answer your question, in either approach that we use, we'll have this like the same situation. So instead of printing this using a comma separated print statement, because the commas will introduce those print statements, you could use string concatenation, d.title. That's a string. We can concatenate it to like, I guess, an dot. And then we can concatenate with, I guess, another string that's like open parentheses, And then concatenate that with a string version of our number of matches. And then concatenate that with a closing. Hello. So like you could use something like this. String concatenation, or we could do a format string. So I'll share both of these. I think I'd prefer a format string myself here. Like we're gonna print a format string, use squigglies to inject some variables inside, including the number of matches, products. And now you can just add those parens in there like that. So these would be two different ways, I guess, of getting those parentheses in there. So I'll share this in Slack as well. How to get the parens in the printed output without spaces. We could use string concatenation or format string. All right. Any other questions? Yeah. Exactly. You could just use an if statement. If the number of matches is something, then we'll have our label be products or product singular. Exactly. So yeah, just implementing an if statement there.